I want to welcome you to the WICOLA Spring 2025 spring meeting. My name is Byron Carnes. I'm sure that most of you don't know who I am. I live on One Pine Lake, and I've lived full-time up here since 2000 when I retired. Bought a place in 2016 on One Pine, and I was very interested in lake associations, and I thought about wanting to start a lake association on One Pine. And then I found all about WICOLA, and I said, I'm going to join this organization. So I joined WICOLA a few years ago. And then I think it was at this meeting last year, maybe, Jeff Pike, who's sitting in the back there, said, hey, would you like to join the board? Right. So I said, yeah, sure, I'll join the board. And I did so. And little did I know that this year, all the board members were going to take turns doing a stint as acting president. So I decided to do March and April. I got to choose that, and I guess I'm going to go into May now as well. So I am the acting president of WICOLA at the moment. We are very honored this morning to have with us Eric Morrison. He is a PhD chemist and lifelong resident of Minnesota. As an alumnus of the University of Minnesota, Penn State, my sister is an alumnus, 3M and Ecolab. Eric has expertise on water quality and its effects on industrial processes, such as chemical manufacturing, wastewater treatment, soil removal, and sanitation. As a volunteer at Northern Lakes Scientific Advisory Panel, he provides knowledge on water sampling, chemical analysis, and laboratory information documentation systems. He has an impressive list as an inventor and has 60 U.S. patents ranging from tape and sandpaper to nanoparticles for pharmaceutical applications. In addition, Dr. Morrison has authored 35 scientific publications. With that, let's welcome Dr. Morrison for his talk on biomagnification of mercury in Boreal Lakes of Minnesota. So.
Thanks for all that, but I got to just tell you, I think I've been kind of oversold a little bit because I'm just a chemist, and I like chemistry, and I like to do things with test tubes and beakers, and it's kind of been my passion. And I've worked for big companies like 3M. When I always, my dad also worked for 3M, and I like to tell people that we worked for like the finest Minnesota mining company. And I was talking actually with Grant Hochschild, and I said, well, my dad and I, we grew up here. We lived here. We in Minnesota. We worked for Minnesota Mining and Manufacturing. And Grant said, what's that? That's kind of my background, and I'm not really much of a public speaker or, persona or whatever. So just, I'd ask you to kind of bear with me a little bit and ask questions. Because my own wife says she doesn't understand me. I love chemistry. I think she does too, but if she has trouble sleeping at night, she'll wake me up and ask me to tell her about things on the periodic table. Really, she doesn't even, we've been working on a periodic table now for years, and I think we've got to healing, which is so it'll be good if you stop me when I start getting a little esoteric on you. So this is a talk about biomagnification of mercury, and it's in the Boreal Lakes. So the Boreal region is really that part of the world where it's subtropical or subarctic. So we have the birch and pine forests. And the thing about the lakes here is that the glaciers really scraped everything and left nothing but hard granite bedrock. And so we've got all these depressions in that bedrock that are filled with water, but that terrain doesn't erode. You know, we don't get the big valleys and things, and we don't have a lot of the topsoil here. And what that means is that the water here is super pure, you know, and it's, you know, it's kind of a chemist that did a lot of work with water quality and water hardness and water alkalinity and how that affects things like cleaning, you know, vessels where they make beer. You know, if you have hard water, it's different than if you have really pure water. And so when we talk about water quality, a lot of times we're talking about water properties. So it means, you know, how much dissolved minerals you have in the water. And then in these lakes, there's not really any dissolved minerals at all. And that's important because it makes the lakes very sensitive to effects. And so this is, the next slide is the presentation. And this is the ecoregion, the next slide that we're really talking about here. It's what the EPA calls ecoregion 50N, which is Boundary Lakes and Hills. And that is that ecoregion that glaciers have scraped clean, and we've got the hard granite surface. So, you know, and this is these ecoregions. Different parts of the state have different terrain and different topsoil and things like that. So they play by kind of different rules, the ecology, and that's why they group this together as 50. And then you can see right here is Birch Lake, and then right there is White Iron, right in the middle of everything. And so we're going to be talking a little bit about, you know, White Iron and Birch in a minute. And so let's go to the next slide. You know, the water is the purest on Earth. It really is. If you want to look for water anywhere on this planet, it's never got lower conductivity than these lakes. Very, very pure. But it also means that there's really no buffering. They're more sensitive to effects. And so we're going to be talking about biomagnification of mercury. So the next slide shows what that is. And have you ever heard this term biomagnification before? You must have heard of PFOAs. It comes from my former company, we have a lot of work with that. PFOAs are perfluorinated alkyl substances, and these materials are fat soluble. And the problem with that is that they biomagnify. Because they're fat soluble, they'll get into the ecosystem, and small organisms like algae get eaten, and then they get eaten by zooplankton, and they get eaten by crappies, and they get eaten by walleyes. And what happens is all of that fat soluble material just gets consumed by the next animal up the food chain, and it concentrates. And the same thing can happen in mercury. And so these are actual numbers here. And if you go to Crane Lake in Voyagers Park, the concentration of mercury in the lake water is 1 part per trillion. And then it increases going up that food chain until it's 1.2 parts per million in a walleye. And that might not sound like a lot, but that's really not good. The other thing is, even though it sounds like 1.2 parts per million isn't that much, that's a 1.25 million times increase from the lake water. And what sets that off is this, it's sulfate. And in this case, it is sulfate from the mines. So there's problems with sulfate coming from Minnesota Power Boswell plant in Cohasset. They burn a lot of coal, a lot of sulfur would go up the smokestack, but they can't do that anymore. So it gets pulled out of the smokestack and it ends up in Mississippi River. So it's not just a mining, there's other activities that put sulfate in the water. But for what we're talking about for the Boreal Lakes, it is mining. And so what happens with sulfate is sulfate, and I know I'm going to say things that you've never heard of before. Now, sulfate is a terminal electron acceptor, which means that some organisms use it like we use air. These organisms, and Jeff can tell you more about this than I ever could. These organisms, they're sulfate-reducing bacteria. They eat food just like we eat food. They eat carbohydrates. They eat sugar. They eat these things, and instead of burning those molecules with air, they burn them with sulfate. And that's all fine and good until we find out that when they do that, they convert mercury into methylmercury, and they make it fat soluble. Just a very curious little thing, but it explains why when you put sulfate in water, you get mercury in fish. This wasn't known in the 50s when taconite mining started. It really wasn't known in the 80s, but in the 90s, it started to become quite evident. Other places, mostly out east, there's a Cindy Gilmore's at Smithsonian Water Institute, and she really really did a lot of work that showed how important sulfate is to mercury methylation. So it's kind of an interesting thing. You know, we started off in a good way because we didn't know there was a problem with sulfate. And now we know that there is, and we got to do something about it, I think. But the thing that's also really curious about sulfate is if you get a Dasani water, and you wonder what is Dasani mineral water, they take water from the ground, they have a well, and they purify the water by reverse osmosis to take all of the dissolved mineral content out, and then they put back into the purified water sulfate. So Dasani water is sulfate. Sulfate is quite harmless to people, and it's actually good to drink. And the irony is it's not good in these lakes because it feeds those sulfate-producing bacteria. And so they convert that mercury, which is, and unfortunately, the whole world is kind of covered with a veneer of mercury. And it comes from mostly from coal-fired power plants throughout the world, and it's spread all over the place. So everywhere we go, there's inorganic mercury, and it really isn't a problem. At 1 part per trillion, it's not really a problem. It becomes a problem when it changes into methylmercury. So the next slide is, how do we study this? And so I'm kind of more of an industrial chemist. I'm not an academician, I'm not a professor. If I was a professor, I'd probably do a scientific paper-oriented research. And scientists would love to, when they are looking for charts and graphs, they usually kind of narrow the field of vision. Because the narrower you make that field of vision, the better the data looks and the better the charts look. And in the publications. But there's another thing that we can do, and that is we can, get out of the lab, get away from the test tube and beavers and go right into the lakes. And this is, called, the direct study of mercury methylation. The thing that we need to do that is we really need data, good data, and a lot of it. Because they get rid of the, extraneous confounding variables by just narrowing the field of view. We're going to make that huge. And the way that works is if we have enough data that things average out. And so the thing that really helps us here is the MPCA. So the next slide. On the next slide.
Hey, just a second here.
The MPCA has a lot of data on it.
Sorry, it's
Frozen.
Frozen up on me, yep.
So the NPCA has a database called the FCMP database. It's a fish contaminant monitoring program database where they monitor contaminants, mostly backyard contaminants in the fish. Methylmercury, PFOA. This is all the data that the NPCA has for mercury content in walleyes in Plain Lake. And so little walleye doesn't have much mercury, but when you get up here, that is a lot of mercury, and it all averages out at 1.2 parts per million in Plain Lake. But we really need to have this many data points in all these lakes to average them out and be able to start to study what does sulfate have to do with mercury. So the next slide, before we move from this slide, this is available from the NPCA. They do not put it on a website like they put a lot of their data. This data, you have to request it. And there's a link there that you can request that data, and they'll send you the database. The database is an Excel file, and it has 64,000 rows, 72 columns. It can be a little bit
Easy to work with.
you know, if you ask the right people at the NPCA, they'll tell you how to use, because it's an Excel file, we filtering and sorting to find, those data for Plain Lake. So they'll help with that, but you have to request it. They just don't put it out. A lot of their data, like if we want to look at, sulfate concentrations in Fall Lake, we could go to the website and pick that up really quickly. But the database for mercury and fish, you have to just request. I'll send it in a couple of days. So in this part of the country, the water's moving north. And, in Fall Lake, that's on the path from Birch Lake, Polishly River, White Island, Garden, Fall, Newton. Then we'll get into Pipestone Bay of Basswood Lake, down to Basswood Lake, we'll end up in Crooked Lake, and that's shown right here. And there's really just one mine that's polluting the boundary waters right now, and that's North Shore. And it's really not that bad. And that's important to note that it's not that bad because it can be capped. It might not be, the train may not be able to stop it. It could slow down. And it's not that bad yet. But there is sulfate. You can detect it all the way up to Crooked Lake in the boundary waters coming from North Shore. And the more serious problem is over in the Voyager Park Lakes, because we have 2 mines discharging water into that watershed. And so what we're going to talk about here in a minute is we're going to start with a little trip starting in Rainy River at International Falls. So we're just going to work our way upstream all the way to the mine. And we're going to measure the sulfate concentration the whole way. And that's the next slide. And so here we are at the Rainy River in International Falls as it drains Rainy Lake. And we're going to go across Rainy Lake. This is Namakan. This is Sandpoint, Crane Lake, then up to Vermilion River, through Lake Vermilion. Here's the Pike River that goes into Lake Vermilion, and it just keeps going out. By the time we get close to the mine, it'll be 77 parts per million sulfate. And down in the Rainy River, it's 2.5 parts per million sulfate. And that doesn't seem like a lot, but it really should be 1A. That's what sulfate is, because this is really pure water to start with. And so, what does that mean? And what we're going to do is we're going to go on to the next slide, and we're going to look at how sulfate changes what's going on in Crane Lake and in Sandpoint Lake. And so you remember that sulfate is just decreasing steadily as you go downstream. And so we get this range of sulfate concentrations in these big lakes. Now, the thing that's really important here is it's not a test, but it's not a beaker, it's not a mesocosm. These are the lakes that people fish. This is the direct study of mercury methylation, and this is what really matters. And we have this spread of sulfate concentrations because as that plume of sulfate from these mines goes downstream, it gets diluted by water coming in from the site. There's, can we go back one slide here? There's a big jump right down here. There's a big dilution that happens here going into Namacon because the Namacon River is coming in from the WICOLA, and that's a massive influx of clean water. So we see a big jump down there. And that's why on this slide, we have this, on the next slide, we have this spread of sulfate values. Now we're just going to go and take that FCMP database and we're going to calculate the amount of mercury on average in these walleyes and crane lake walleye. And we're going to plot that against the sulfate concentration. This is what we get. There's no doubt that these things are right. And there's really no doubt that we really want to do whatever we can to not continue to put this much sulfate into the environment. And so one of the things that I think people really don't want to hear, and I actually don't really like to say it that much, is that if you take a walleye from Crane Lake, which we all think is really clean water in Boreal Park, and you compare the mercury in that walleye to seafood that the FDA monitors, the Crane Lake walleye would be number 2 on the list of fish to avoid because of mercury. The only fish that has more mercury in it in a commercial seafood than a Crane Lake walleye is a tilefish from the Gulf of Mexico. This is really not what we want or deserve in Minnesota. And there is a solution that we can work to address this. And that's, that's where Jeff comes in. Because we need to support these efforts to take that sulfate out of water. This is not a finger-pointing exercise. I think it's been great for people to, it's been great conversation, if you call it that. But that doesn't accomplish anything. I think we really are, the ilk that we're going to roll up our sleeves and try and work on this and make them better. And so, one of the things that we're, doing as volunteers is backstopping Jeff and Bill Newman's work on removing that sulfate, from the chemistry perspective. So as a chemist, if there's some things I can do for the analytical chemistry or whatever, we're doing this kind of a donation kind or a pro bono. This is what we can do to make things better. So anyways, going on to the next slide. This is the boundary waters, but it also is Fall Lake, Garden Lake, and White Iron Lake. And so we're going to start here at Crooked Lake, and we're going to go upstream all the way to Birch Lake and up the Dunker River until we get to where North Shore 9 is the dumping water. And this is the sulfate here. This is a little different scale here because it's not that bad yet. And what we want to do is to keep it from ever getting that bad. So here we are at 10 parts per million. The other one, the scale went up to 25 parts per million. And again, this is what it is in the normal environment. And, here's what I had. So the next slide shows the data from both watersheds together. Here's the Voyager Park watershed. A lot worse, 2 mines, it's scaling spaces rather than just 50 watering. So it's quite a bit worse, but this is going this way. This is going that way. And I think we have an opportunity now to say, let's just put a stake in the ground and let's not increase that. And then let's work on ways to address this issue. And the question is, what would it look like in Minnesota if somebody, like Jeff, came up with a way to just take the sulfate out of the water. What would life look like then? I think that's what we all really need to put our heads together and try and get to that however we can. So anyways, the next slide is, another kind of dicey conversation here. Because, people, there seems to be an invitation from people that work at power companies and mining companies to engage in this conversation. And to, maybe we're going to work quietly, roll up our sleeves and work quietly, not make a big splash about it or have a lot of headlines or whatever. But we all want to make it better. But it is something that takes time and patience, and Jeff and I and anybody that's really done a lot of industrial chemistry knows that you really have to scale this up. You start out with working in your basement or in a garage, and then you do it on a pilot plant scale. And that's where we have to take this. We'll know if this will work to remove sulfate when we get that chance to get up to bat. And to get up to bat, there's something that's required, and this is, I would say from the horse's mouth themselves. This is somebody that knows the powers that be enough to say that they cannot possibly imagine cleaning sulfate out of water unless they have a directive to do that. So Minnesota Power can't say, we're just going to voluntarily clean sulfate out of the water, because they have shareholders that they are responsible to, and that's just not what they can do. Is just start sending water to help or get the good thing. They need a legislative mandate. So now we're going to open up this whole big can of worms about what would that look like. And I can tell you some things it wouldn't look like. It won't look like some absolute kind of thing where you're just banning all mine wastewater discharge, because you can't do that. They're not going to close the mines. What we have to do is we have to find a way to move forward together. And I think we really need to respect the hard work that people have done on both sides of the equation. There's a lot of people that take a lot of pride, and rightly so, in having lived in Babbitt and having worked in the mines. It's not easy work. It's 40 below, and they have to go to work. And, this is Minnesota, where people do that kind of thing, and they don't deserve to be shamed for having done that. But, it's not, it's like a far cry to say people should feel bad about these problems. People didn't know this was a problem 30 years ago. Now that we know it is, it's time to get beyond all this rhetoric and let's get to work here. And so there's a bill that's been kicked around in the main, I guess the main, original draft is from small groups. So the larger groups are really kind of busy doing other things, like the Isaac Walton and Boreal Lakes Scientific Advisory Panel. And with some help from Jeff, what would it really look like to have something that kind of can move us all together? And, one way to look at it is, what if this sulfate wasn't an issue? And this problem with mercury methylation, what if that wasn't an issue? Maybe we could all be good neighbors again. I think I've been coming up to Ely since I was a kid. I remember Becky Rom, when her dad owned the New Country Outfitters, that's where we went. And Ely was different back then. What would it look like if we could all be friends again? That's what can happen if we just can go over so and address this problem, I think is what I'm saying. So there's a bill. It's being kind of kicked around, and it's more of a bill about how can we work together to make this better. It's a contract. It's not aimed at vilifying anybody. You know, it's not aimed at calling out bad actors or that kind of thing. It's aimed at, let's see if we can find a way to work together. And so that's about all I have to say, and nobody asks any questions. I just keep on going here. But I imagine you must have some questions about all this.
Who actually is monitoring all of this? Is it the mining company, or is it an outside group, or is it many outside groups that are determining, you know, what the effects are?
Yeah, so that's a great question. The FCMP, the Pollution Contaminant Monitoring Program, is overseen by the Minnesota Pollution Control Agency, but they did not do all of the testing. And it's the same thing for the sulfate data. They didn't do most of that sulfate testing. So there's different groups that are so-called accredited by the MPCA and Northern Lake Scientific Advisory Panel is one of those. And what that means is that we can go out and get water samples, have those analyzed, and then we have to follow a lot of procedure with chain of custody and collect collection of the sample and so on and so forth. There's a lot of data that goes involved with that. But once we do that, the data that we collect gets uploaded directly to the MPCA's database. So they're really the owner of all this data. But a lot of groups that contribute. So,
including WICOLA,
yeah.
the water monitoring we've been doing for many years, follows those same protocols and everything and gets uploaded to the official MPCA website and becomes part of this database.
Yeah, WICOLA has been doing 50 samples, five times a year, 10 sample sites. And we're looking at possibly expanding to a few other lakes this year.
Oh, we are.
His lake, he's going to do the sampling.
One thing that I think is kind of interesting is the MPCA, they hear all kinds of different things about the MPCA. And one thing I've got to say is that it's not a monolithic organization. It's made of individuals. And most of the people are really passionate about what they do. And for the most part, the MPCA is like, you guys want to sample water and boundary waters, so forth. We simply can't do that. It's a real problem, kind of think from an insurance point of view, that have your employees take municipal shortages for some reason. Or maybe it's just that, for the MPCA, it's like you send somebody up to Crooked Lake, it kind of looks more like a paid vacation and not a water sampling thing. But for us, it really is a vacation, although when we sample water in Crooked Lake, it means we have to carry enough ice to travel through the boundary waters to keep the samples full once they're collected. But it is a vacation for us, so it's kind of a win-win.
Where is the sample coming from? Are they coming from high levels of the lake or certain depths? Or
Great question. Doesn't matter. That water just gets mixed. If you look at, like the Twin Lake situation, that water has been mixed quite thoroughly in their political. Yeah. So, and it doesn't matter where in some lakes like Vermilion and Birch, it doesn't matter where you sample because both Vermilion and Birch have clean water coming in some places and the water from the mine in other places. So if you move around, you'll see it's pretty variable, but depth-wise, it's a difference.
However, it seems to me that when we go do our sampling on the chain, we have this big tube to pull a column of water about maybe 10 feet down.
For sulfate, you don't have to do that.
So
Yeah. For other things, and that is a procedure, so you get a standardized sampling method, so you're always doing it the same kind of, do away with those doubts about that. But sulfate, like, take a glass of water, put some salt in it, it's going to disperse evenly through all that water. Sulfate is a salt, and so it tends to get dispersed through that whole water body. Okay, just like salt would, or stirring sugar in your tea or whatever. You can't put salt in one corner of the cup and not have it in the other. So sulfate being a salt gets through the whole water column.
And does it tend to concentrate then in sediment? So what
Sediment
sediment
is-
different story?
Well, the problem that we're having occurs in sediments. Because it's sulfate in the water feeds sulfate-reducing bacteria at the bottom of it. Because this is something that happens in the absence of oxygen. If there's oxygen around, sulfate-producing bacteria do not really deliver. But, that it just depends upon which layer they all have at the bottom. But some of them, that bottom is pretty shallow. And sometimes if you're on, like a little river like the Dumpy River, you poke the bottom a little bit and you might smell that hydrogen sulfide. It doesn't have to be too deep to get those antioxidant conditions.
That makes me think of the fact that warmer water can hold less oxygen, which means with climate change and water warming, there'll be less oxygen and more bacteria using sulfate, potentially,
If you have the sulfate.
if you have sulfate, yeah. Yeah, if we take it out, then it's a moot
Yeah.
point. But as long as it's in there, it could be exacerbated by warming.
There's another thing that's also related to climate change that we really have to think about, and that is invasive species.
Yeah.
And one invasive species that really causes problems with biomagnification is spiny water flea. And the reason why spiny water flea is such a problem is that spiny water flea is not what the little sunnies or anything like that want to eat. They want to eat daphnia and other organisms. Spiny water fleas are spiny, I guess, to make it hard for fish to eat them. And what happens then is, spiny water fleas will eat all of that algae, clean up the make the water clear. But they also make the effects of biomagnification worse. So the more nutrient poor a lake becomes, the more the concentration of mercury is going to increase in the water fish. And that's something that happened really big time in Michigan, where invasive species, I think zebra mussels are also a problem because they kind of clean up the water and remove nutrients, but they just make it so that a bigger fish has to eat a lot more little fish to get real power. And we have more problems with, biomagnification. I think, I guess things can only get worse. But, yeah.
Well, it's my understanding that the sulfate coming from the river line and from Dr. Pitt is largely from sulfate bearing overburden that was removed to take access to the ore body. Whereas the elephant in the room here is copper nickel mining. Sulfide copper nickel mining is the sulfate contained in the ore body itself. So once they crack that open, there's a perpetual chain reaction of percolating sulfides into the watershed at levels much greater than what we're seeing now.
Yeah, that's a real big issue here because, with taconite mining, we're going to get a pound of metal and maybe 2 pounds of tailings. When we go to copper nickel, it's going to be 1 pound of metal and 99 pounds of tailings. That's bad. But it gets worse because taconite mining is really going after low sulfur ore bodies. Taconite occurs in relatively lower sulfide, and on the other hand, copper nickel is really targeting the high sulfur ores. So there's a really big problem. Now there's something to be said about, there's a few things to be said about polymet, because when we talk about kind of bad actors, polymet is been a pretty bad they were doing. They, for one thing, they worked them under the table deal somehow to get their water discharge. And when they did this under the table deal, they got a permit that they were going to be operating on 30 square miles of rock, their tailings basin, their hydrometallurgic plant, their pit. It's going to be 30 square miles of area that they were working on. And for that 30 square miles, there was only one single surface discharge site that had any limits of pollution on it at all. One surface discharge site in 30 square miles. And I don't think you really need to know more than that. That's not enough. Limits. But if we look at that one surface discharge site, it was SB001. And the limits were crazy. There was no limit on sulfate. None at all. In Mercury, the limit was 1,000 nanograms per liter. So 1,000 parts per trillion as a calendar monthly average. And if you're reading my slide about what is the concentration of mercury in Flame Lake, it's and their limit is 1,000 parts per trillion. This is insane. They must have been laughing all the way to the bank when I got that permit, which is just like do it all you want, because there's no restraint. Now that didn't pan out for them because they got caught with their kind of under the table dealings. And I don't know what they're going to do when they come back, but I think they got a lot more to go to be a better way to involved and to talk a little bit more real about it. Because, this kind of mining really needs to be done carefully. And these mine plans and these water discharge permits really need to be done a lot more openly, under the table kind of deals. People need to be able to see what they're doing. And we really need to, get polymet in particular to be better at it. Yeah.
At the end, you talked about the legislation, the non-voters in the state of Minnesota, but we financially support candidates. A lot of candidates out here, issues like we're talking about today. Who introduced, where is this piece of legislation stand? Is it introduced? Who introduced it?
It's not introduced, and I have to say that the person who probably knows as much about where it's going as anybody is Don Siegmeyer, who's the president of the Lakes in Minnesota, and he's not here today because he's in Austin because they're having a meeting there. And, he has a kind of a one perspective on this because he worked for the DOT for a long time. And he's worked with legislators on both sides of the aisle. And I can tell you this, that I met with John Siegmeyer and, Jim Carlson, if you know who that is. He's a senator from Michigan. And, Jim Carlson worked at WICOLA. So did I. So kind of a natural place to go and ask this person's a long-standing senator and a very conservative guy, but he's a Democrat. He's very conservative, and asked him what should we do about this? And I think his answer was, you really have to talk to other senators in Minnesota, and we're kind of in that process. We're talking about, I mean, the people that we talked to are really a little bit surprising to. One of them is Van Hoshad, and no real information about what happened there, except he seemed like a nice guy, and he was very sympathetic to this idea of cleaning something out of the water. And there's some other people that, are kind of, one thing that's happened is, this kerfluffle has ended up being a lot of Republican Democrat kind of thing. Then a lot of up north, down south, then a lot of rural versus city folks. Nobody's ever been able to move beyond that. That's not at all appropriate. We're all neighbors. We shouldn't be thinking about things in terms of, who identifies with who. So as this is going, it won't come out in the legislature this session because there's all kinds of problems down here. But it just goes through, and maybe it won't ever get anywhere. I don't really know who's going to be involved, but it's probably not going to be the quote unquote legal side that it's going to, probably be more broader, mix of people than some of these things that have passed. But that's all I know. Does that sound fair?
I don't know, you guys.
I guess the one thing
I hear
that
from
we're
you.
really trying to do is to get working on getting the sulfate out. And, there's the LCC, I'm taking all your time about the LCC now because this is something we've got to get.